Hello, welcome to our class, and today we are going to learn mathematics. We are going to learn complex numbers. So let's begin. Hello to our class, and in this video we are going to learn about complex numbers. So this is the complex numbers. So first we have to rub this thing off. This was written prior sometime earlier. So this is the complex number. But before learning complex numbers, we have to know about what are imaginary number. What are imaginary numbers? Any number, square root of any number that is negative. Let's say -1 is negative square root of -1, -2, etc. These are imaginary number. These are imaginary numbers. So there is something special about this number. This is the square root of -1. This is very special because it is called iota, I. This is very special number because all numbers such as this one, -3, etc. can be formed using this I, which is equals to -1. So if we take the square of I, this becomes -1. If we take cube of I, this becomes -1I, that is -I. If we take I to the power 4, this becomes I square equals to -1 square equals to 1. So these we have to remember. The first power of I, this is the first power of I, which is equal to square root of -1. Second power of I is -1. The third I raised to the power 3 is -I, and I raised to the power 4 equals to 1, and all other, let's take I 129. When we divide 129 by 4, that's 32. 1 by 4. So this equals to I to the power 32 into I to the power 32 becomes 32 into 4. So this becomes 1 into I equals to I. So any I to the power raised to any number n can be written as I to the power m into 4 plus I square I to the power 3, I to the power 4. So all numbers, all I to the power n can be written in form of this, and I m into 4 becomes 1, then this becomes in the form of either I square, I cube, or I to the power 4. All of 1, 2, 3, 4. All these values are written here. I to the power 1 equals to minus 1 under root and minus 1 I square equals minus 1 I cube equals to minus I, and I raised to the power 4 equals to 1. All these parts are written. So we have learned about imaginary numbers. No, wait. No. One thing we have to note here, that let's take a number minus 2 and multiply it with minus 3 under root. This doesn't become minus 2 into minus 3. This is a fallacy. This doesn't equal to that, because any number m into n, this becomes mn only if either m or n is a non-negative number. That means either m or n is equal to 0 or a positive number. Only then this happens, otherwise it's a fallacy. Now, since we have learned all this about imaginary numbers and I, we have learned about imaginary numbers and I, the 4 powers of I, that those are fundamentals, and the rest depend on these 4 powers only. So we have learned this far. Now we will come to complex numbers. Nothing to fear about it, but hereby we come on complex numbers. So we erase all this, rub them off, and so we come to the topic of complex numbers. So we had learned about I. Now any number in the form of a plus bi, where a and b are real numbers, a and b are real numbers, in I equals to minus 1 square root of minus 1. So this is the form of complex number anywhere. The complex number, say 5 plus 9i, or let's say root 3 plus root 2i, or 5 minus root 8i. These are all complex numbers, because the great thing about it is if this equals to z is a complex number, a plus bi, and when a is the real part of z. The real part of z is a, and b is the imaginary part of z. These both are real number, but one is the real part and the other is the imaginary part. And when the real part of any complex number z equals to 0, then it becomes bi, where a 0 plus bi. Bi is the complex number. This is the purely imaginary number. And when b is 0 and a plus 0i equals to a is purely real. A is purely real. So when the real part is 0, the complex number, and when both are 0, 0 plus 0i, it becomes equals to 0, which is not a complex number. Complex number are denoted by C or Z in this case. So 0 is not, I'm not sure if 0 is a real number. Yes, it is a real number. Purely real, purely imaginary, but if it is a complex number or not, I'm not sure. 0 is a real number. So complex numbers contain real numbers and imaginary numbers, both. So every real number is a complex number, and every imaginary number is a complex number, and every number in the form of bi is a complex number. Now we will talk about conjugate of a complex number z equals to a plus bi. The conjugate is denoted by this, and equals to a minus bi. Only the sign of the imaginary parts, that's b, only the sign of the b is changed. If it is plus b, it will be converted into minus b, and if it is minus b, it will be converted into b plus b. So any number, say 9 minus 5i, this would be 9 plus 5i. Only the sign of the imaginary part is changed, and the real part is not changed, and I is also not changed. Then we have the modulus of a complex number z equals to a plus bi. Modulus is denoted in this form, and equals to a square plus b square whole under root. And so definitely the square of the modulus equals to a square plus b square. This would be used in later sections. Now it's time to rub this thing from bottom so that we have the complex number at the top. So we have rubbed this far. So let's say z1 is a complex number, a1 plus b1 I, and Z2 is another complex number which equals to A2 plus B2I. And when we say that Z1 equals to Z2, this can happen only when A1 equals to A2 and B1 equals to B2, and I remains the same always. I doesn't change. So this is called the equality of two complex numbers. Later on we will talk about sum and difference of complex numbers. Then we have properties of addition on complex numbers, the commutative law, associative law. Then there is existence of additive identity, then existence of additive inverse. Then comes the multiplication of complex numbers, and there are another properties for multiplications as well, such as closure property, commutative law, associative law. Then there is existence of multiplicative identity, then there is a multiplicative inverse, and there are distributive law. Then we will learn about division of two complex numbers, and then we will solve the problems. So that was it. Hope you liked to learn about complex numbers. First we had learned about imaginary numbers, then I, then all those things. Then we learned something apart from that. That was quite a learning, and I hope you guys liked it. So hit the like button even if you didn't like it. So we will conclude here by rubbing it off. Goodbye, have a great day. Wow, this was real fun. Complex numbers, that was great. So goodbye for now, have a great day.